Hello, this is section 9.2, solving quadratic equations by completing the square. Part 1, completing the square. Binomial square patterns. If a and b are real numbers, then a squared plus 2ab plus b squared equals the quantity a plus b squared, and a squared minus 2ab plus b squared equals the quantity a minus b squared. Example 1. Identify a and b in the following perfect square trinomials, then rewrite the expression as a plus or minus b squared. So remember, a squared and b squared are the first and third term if written in descending order. So in this case, that would imply a is equal to x and b is equal to 9. The other thing you should check is that the middle term is double these two terms. So x times 9 is 9x. Double that is 18x. So that works. So that means this will be x plus 9 squared. Well, here we have a is equal to y. B is equal to 7. And again, you just need to make sure y times 7 is 7y. Doubled is 14y. So this will be y minus 7 squared. And again, it's minus because the 14 was negative. Example 2. Determine a and b in the following perfect square trinomials. Then find the last term of the trinomial b squared and rewrite the expression as a plus b squared. Well, this time, a is still just as simple to find because a will be equal to x in the first part. But since we do not know what the third term, we have to think a little bit about what b is equal to. But remember, 2ab has to equal the middle term. And since a is equal to x, to get b, I just divide by 2x. So I get that b is equal to 3. So in other words, b is equal to, no, I'm not going to write that. B is equal to half of that middle term. So then I need to add 3 squared, which is 9. And then this is equal to x plus 3 squared. Same thing here. We have a is equal to x, and then we get 2ab is equal to negative 26x. Again, that a is x, so I'm just going to replace it with x. Divide by 2x, divide by 2x. B is equal to negative 13. So again, I could have just took half of the 26 to begin with. 13 squared is 169. How to complete a square, x squared plus bx. Step 1 is identify b, the coefficient of x, find half of b, then square it, the number needed to complete the square, add 1/2 b squared to x squared plus bx, factor the perfect square trinomial by writing it as a binomial square. So we're going to complete the square in these following trinomials. So this time I am just going to skip identifying what a and b are and I take half of the middle term, so half of negative 20, and then squaring it. So that becomes negative 10 squared, which is 100. So I'm going to add to 100. Now it's a perfect square trinomial. It will factor a minus 10 squared. Part B, p squared plus 1/4 p. Well, I'm going to take 1/2 of the 1/4 and square it. So that is 1/8 squared, which is 1/64. So I add 1/64 here. And now I want to factor this. But remember, because this is a perfect square trinomial, it will factor as p and then this number. So it is important to show all your steps because this is a middle step number we need. So plus 1/8 squared. X squared plus 6x, well, we've already done this one. We know it's 9 we have to add, and it's x plus 3 squared. Same with x squared minus 26x. It's 169 we need to add, and it becomes x minus 13 squared. Part 2, solve by completing the square. Recall, when solving equations, we must always do the same thing to both sides of the equation. Our strategy here is to complete the square by adding the same term to both sides of the equation to make a perfect square trinomial. Rewrite the perfect square trinomial as a binomial squared and use the square root property. We will then solve the resulting two equations and check for extraneous solutions. So now the reason why we're going to be solving by completing the square is these equations can't be solved using the square root property directly and or cannot be factored. You should always try those two first because they're easier to do. But here, I'm just going to follow directions and complete the square. So I need to take half of this coefficient, so 1/2 of 4, and square it. So that's 2 squared, which is 4. So I need to add 4 to both sides of this equation. So we get x squared plus 4x plus 4 is equal to 9. Now the entire reason why we added 4 to this equation is so that we can factor it now into x plus 2 squared equals 9. And now we can use the square root property. So take the square root of both sides and get the absolute value of x plus 2 is equal to 3, which means x plus 2 equals 3, or x plus 2 equals negative 3. Subtract 2 from both sides of both equations, we get x equal to 1, or x is equal to negative 5. Now you should check both of the solutions, but they do work. Part B, y squared minus 10y equals negative 9. So I need half of that coefficient, which is negative 10, squared. Half of negative 10 is negative 5, squared is 25. So I'm going to add 25 to both sides here. And we get y squared minus 10y plus 25 is equal to 16. That now factors as y minus 5 squared equal to 16. Take the square root of both sides. We get absolute value of y minus 5 is equal to 16, which means y minus 5 equals 16, or y minus 5 equals negative 16. And I forgot to take the square root. The square root of 16 is 4. So y minus 5 equals 4, or y minus 5 equals negative 4. And then add 5 to both sides. We get y equals 9, or add 5 to both sides, y equals 1. And both of the solutions work. X squared plus 4x equals negative 21. Well, we've already done x squared plus 4x, so I know I have to add 4 to both sides. We get x squared plus 4x plus 4 is equal to negative 17. Factor that left-hand side, we get x plus 2 squared equal to negative 17. Take the square root of both sides, we get the absolute value of x plus 2 is equal to, and now we're taking the square root of a negative, so this is where we need a complex number. So I square root of 17. So then we get x plus 2 is equal to I square root of 17, or x plus 2 is equal to negative I square root of 17. Subtract 2, and we get x equals negative 2 plus I square root of 17, or x equals negative 2 minus I square root of 17. Part D, we have z squared plus 8z equals negative 19, so I need to take half of that middle term and square it, which becomes 4 squared, which is 16. So I'm going to add 16 to both sides of this equation. We get z squared plus 8z plus 16 is equal to negative 3. The left-hand side factors as z plus 4 squared, which is equal to negative 3. Take the square root of both sides, we get the absolute value of z plus 4 is equal to I square root of 3. So z plus 4 equals I square root of 3, or z plus 4 equals negative I square root of 3. Subtract 4 from both sides of both equations, and we get the final two solutions of z equals negative 4 plus I square root of 3, or z equals negative 4 minus I square root of 3. I think that's a good spot to end for this video, and we'll finish the notes up in the second video.